Are you trying to generate a two-dimensional tensor filled with values from a uniform distribution in PyTorch? If so, you're in the right place. Today, we will walk through how to achieve that effortlessly. I completely understand how challenging it can be to work with random distributions in programming. It can feel overwhelming, especially when you're trying to get specific results. You're definitely not alone in this struggle. Here's the specific question we're addressing today. One user asked, how can I get a two-dimensional tensor with size a by b filled with values from a uniform distribution in the range from R1 to R2 in PyTorch? If this sounds like your question, let's dive in. So what does it mean to create a tensor with a uniform distribution? Essentially, you want to fill your tensor with random values that are evenly distributed between two specified limits. This is a common requirement in machine learning and data processing. And stick around. At the end of this video, I will share a quick tip that can help you optimize your tensor operations in PyTorch. To create a two-dimensional tensor filled with values from a uniform distribution in PyTorch, the user should first import the necessary library. This is done by using the import statement for PyTorch. Next, the user needs to define the dimensions of the tensor. They should specify the size as a tuple, where A is the number of rows and B is the number of columns. Now the user should set the range for the uniform distribution. They need to define the lower bound R1 and the upper bound R2 for the values. After defining the range, the user can create the tensor using the uniform distribution function. They should use the torch.empty function to create an uninitialized tensor and then fill it with values from the uniform distribution. Finally, the user can print the resulting tensor to verify that it contains the expected values from the uniform distribution. Fun fact, the concept of uniform distribution is used in various fields, from statistics to machine learning. It's fascinating how math plays a crucial role in technology. Now let's look at the answers provided by other users. An alternative approach to generate a uniform distribution in PyTorch is to use the uniform distribution class from the Torch distributions module. You can create a distribution by specifying the lower and upper bounds. That's the end of that answer. Let's see another perspective. An alternative approach provided by a user involves using the PyTorch library to create a tensor filled with values from a uniform distribution. They suggest using the empty function to initialize a tensor and then applying the uniform method to fill it with random values within a specified range. Let's take a moment to review another user's answer. An alternative approach provided by another user involves using NumPy to create a random matrix. They find the NumPy API easier to understand. The method starts by generating a uniform distribution matrix with specified low and high values, and then it converts this matrix into a PyTorch tensor. Let's take a look at another answer from another user. An alternative approach provided by another user involves using PyTorch's built-in distributions. They suggest creating a tensor filled with values from a uniform distribution by utilizing the uniform class. Now, let's see a response from a different user. An alternative approach to generating a uniform distribution in PyTorch involves using the uniform distribution class. First, you can generate samples using NumPy, then create a sampler with PyTorch's uniform class. This allows you to sample directly from the distribution. The user also notes that using a sampler can be beneficial for transforming or caching distributions. The user mentions that while they find the sampler useful, they are unsure of its necessity compared to directly sampling in one line. They also highlight that the sampler can accept tensors for high-dimensional intervals, making it versatile for various applications. Here's that quick tip I promised. Always ensure that your random seed is set for reproducibility. This way, you can generate the same random numbers every time you run your code. And there you have it. You now know how to create a two-dimensional tensor filled with values from a uniform distribution in PyTorch. If you found this video helpful, please subscribe for more tips and tricks.